Hello everyone, my name is Ivo, and welcome to our Symposium. This project has worked on developing a product based on biodegradable mycelium. In this presentation, we will tell you about the material, the production method, the research we did, the coating we made, and finally, the design process of the end product. Let's start by taking a quick look at the mycelium as a material and the production process. So what is mycelium? Mycelium are the roots of the fungi. As you can see in the sample, the core of the product are the hemp fibers. Once a fungi is attached to the fibers, the roots of the fungi start growing through it. This results in the material. This is also what gives it the interesting material properties. Mycelium has an incredibly high insulating value. It is also fireproof, lightweight, water resistant, very cheap, and most importantly, fully biodegradable. So now let's have a quick look at the process we have to give us this final result. Starting off, we have the raw hemp fibers. These come pre-shredded to about a size of 10 millimeters. At first, the material is cooked to fully sterilize it. This prevents contamination later on in the process. After this, it enters a phase we call pre-growth. In pre-growth, we put the hemp fibers in a chamber that is that has a controlled temperature and humidity. In this chamber, the mycelium starts growing. After about 2 to 3 weeks, the mycelium has fully grown into the hemp fibers. At this point, the hemp fibers are broken up and shredded. Shredding the material allows it to have a greater detail in the final product. Once it's been shredded, we put the hemp fibers into the mold. After about 2 to 3 weeks, the new hemp material has fully taken over the shape of the mold. After this, once this has been finished, it is very important to dry the material. And so we put the mold into an oven and we bake it at about 200 degrees. This results in our final product. Great. Now Celine will tell us something about the further research we did into mycelium as a material.
Alright, so we did some experiments on the biolab. We first wanted to try and proof concept of the vegan leather to see if we could actually make vegan leather. What we did was make a gel-like solution and a liquid solution. We added the spores on it and we added some nutrition so that the spores of the fungi could grow on it. Our results showed that the shiitake fungi actually grew pretty good sheets. So we could actually make vegan leather out of shiitake fungi. However, the oyster fungi didn't grow as well. They just got clumps all over and it just wasn't good enough. Because it was a proof of concept, we didn't go into it any further, but it was nice to see that we could actually make it and our clients maybe could go on and finish what we started. The second thing we did was try and add some growth enhancers so that the growth would speed up, so it would take less time to actually grow his product, the client. We tried malt, starch and flour. Our results showed that malt actually enhanced the growth quite well. The flour and starch didn't. They actually contaminated a lot of things, so we didn't use starch and flour again, but we used malt. And the last part that we examined were some parameters of the material that we actually made, so the products, things like strength and density. Density we did by weighing the products before and after a lot of water was evaporated, and then we use a formula which we can calculate the density for products. And that's about it, what we did on the lab for so far. I hope you understand all what I'm saying.
Very interesting. Now we'll listen to Melvin as he's going to tell us something about the research we did into the coating of the final product.
The coating has two main properties. The first is to protect the mycelium and the second is to decorate it. The mycelium needs to be protected to outside effects like water vapor, fire and UV light. A solution to protect the mycelium against those effects is to add a coating to it. After some literature research, potato starch was chosen to focus on as a coating matrix. Next, cheap and environmental friendly additives were searched in literature and compared in a matrix. The best 3 were selected and tested. The coatings were in the end produced and tested on quality and their ability to protect against the named outside effects. The best and most accessible coating seemed to be a glucose glycerol coating made from potato starch and glycerol. The coating was chosen for the fact that it was a cheap and accessible option. The client, McAllen, does not have the ability to use expensive methods and machinery, so it was the perfect option for the company. The additives chosen to do research to were betylene, extracted from birch bark, caramel and linseed oil. The additives were added to the coating and researched. Unfortunately, the additives did not seem to have any big effect on the properties of the coating to protect it against UV light, water vapor and fire. The mycelium without coating already seemed not affected by water and fire. In addition, the quality of the coating was lowered by adding additives in such a way. The question should be asked if they should be cut from the coating completely. There was chosen to cut the additives that were expected to protect against outside effects. Research has shown that mycelium itself already has water and fire repellent properties. However, the food coloring additives were gray and showed a homogeneous color in the coating. It did also not have any effect on the quality of the coating. The conclusion of the research is that the glucose glycerol polymer is a great opportunity to use on mycelium products. The mycelium already shows protectiveness against fire and water, so a coating to protect it against those things is not really necessary. However, the coating can also be used as a decoration by adding food coloring or using natural extracts like beet juice. Recommendation is that next research can be focused on optimizing the coating and further develop its quality.
To start our product development, we did a trend analysis to see the upcoming opportunities. This will allow our client to find relevant needs and help us create a product that is better suited to the consumer. The first trend is about cradle-to-cradle products. There are more and more companies that are aware of the full life cycle of a product. The second trend is sustainability. It is currently interesting for companies to be associated with sustainability, and companies are often willing to spend large sums of money on this. The final important trend is aging, especially in Europe, which will provide companies with a unique target group. During our project, we looked at the relevant master trends as well. In terms of microtrends, we looked into packaging, leather trends, planters, and other office decorations. To successfully position the client's product into the marketplace, we did a market research. First, we analyzed the target group and the company's possible competitors, such as Grown Bio, Mogu, and an innovative designer. Next, we created a value proposition map. By looking into the trends at the market research, we also have made a SWOT analysis based on the strengths, weaknesses, opportunities, and threats of the client. To formulate brand awareness, a marketing mix IDA strategy was used. The attention can be induced by drawing attention to the durability of the material. The desire can be achieved by creating an emotional connection between the company and its customers. The interest can be improved by going to events or giving workshops. And finally, the action can be made through social media and the website. After the initial research phase, we found a great deal of product directions. These product directions were discussed with the client to see if he agreed with their relevancy. After we narrowed down our product directions to the 5 most relevant ones, we contacted industries related to the products, such as interior architects. Whilst validating our products directions with an interior architect agency, we met employees of Donker Group. Donker Group is an interior architect that focuses on green design. During the interview, they became very interested in the product. This resulted in a long-term deal between Donker Group and our client, McAllen, in which they will design a product lineup which will be sold to Donker Group's clients. As a part of the partnership, Donker Group helped us with the design choices during our project as well. Our trend and market research concluded that it was best for McAllen to further develop its product portfolio with planters. For the design of the planter, we looked at many different visualization styles that fit with the mycelium material. This finally led to a visual artist named Vertox. After contacting him, we got permission to use some of his stunning designs. Once the design of the product had been chosen, it was time to materialize it. To make the complex shape of the product, a special mold had to be made. Because of the odd shape, the mold is not self-releasing, which means the product cannot easily be taken out of the mold. To resolve this, the mold had to be made from a flexible material, such as silicone. The mold is currently under construction as more silicone was needed to fill the mold. As a temporary solution, we chose to make a different mold that uses a 3D printed cast that will be destroyed once the product has fully grown. This mold has been filled and is currently growing in the laboratory. To increase the potential client base of McAllen, we decided to create a social media page for the company. It is essential to keep the emotional relationships between the client and the customer by storytelling. Sneak peeks will guarantee the transparency of the brand and resulting in a stronger bond. Finally, coming posts will increase the customer's attraction for upcoming products. Finally, we created a website for McAllen as well. One of our clients' wishes was to create a community for people that work with mycelium. In this community, companies could be connected with clients. It will be a place that helped creators familiarize with the material, and ideas about the development could be shared. Thank you for watching our symposium. We hope you enjoyed it. Please ask us if you have any questions.